We need to modify our Quake report app to parse a JSON response from the USGS server and convert it into an array list of earthquakes. So first I asked you to copy over the query utils class that I provided for you in this link. Select all of this text and copy it. Then in Android Studio, go ahead and create a new Java class file called query utils. You can remove the initial boilerplate code and then paste in these contents. Let's collapse this pane so it's easier to read this file. Now you can scan this file to become familiar with it, but let's review it right now. In this class we have a string constant in all capital letters called sample JSON response. Since it's a static final constant value, this means the value will never change. So remember that when we set this constant to equal the response from the USGS query. The special characters like the quotation marks are properly escaped with a backslash character. Then we have a private constructor, which means no one should create an instance of this class. This is a utility class, so it will contain static variables and static methods, where you can call the method directly without having to have an object instance of the class. Now the most important method is this public static method called extract earthquakes that takes in no inputs and returns an array list of earthquakes. Within the method, we create an empty array list of earthquakes and return it at the end of the method. We also have a try-catch block, which will handle intercepting any exceptions that get thrown from the JSON parsing code. We'll talk more in detail about the try-catch blocks in Java in the next lesson. But for now, there's a single to-do marked in this method that we left for you to finish. So let's write that together now. Now you could have used the pseudocode we provided you to guide you in writing this code. First we create the root JSON object by calling the constructor and passing in the sample JSON response string. This class will parse the whole GL.JSON string we got back from the USGS API. We'll then store this object in a variable called base JSON response. Now, we're looking for the magnitude, place, and time of the earthquake, so to drill down for that info, we first need the features array. Within the root JSON object, we want to get the value associated with the features key. It should map to a JSON array that contains a list of earthquakes. So let's call the getJSONArray method on the base JSON response object, passing in the features key as a string. We can then store the result in the earthquake array variable, which is of data type JSONArray. At this point, we want to loop through each earthquake in the earthquake array, so let's start with a for loop. If you want to review loops and for loops, you can check out the notes below for a video from the last course. Now we began creating a loop by initializing the counter variable I to be 0. Before each iteration of the loop, we test that the condition I is less than the length of the earthquake array is still true. If it is true, we can execute all the lines of code within the loop. At the end of one iteration, we increase the value of I by 1, indicated here by the I++ syntax, and then we can go ahead and loop around again. Next, we can pull out the JSON object at the specified position of the earthquake array. We start with position 0, which is the initial value of the counter I variable. Once we have the current earthquake JSON object, we can extract out the JSON object associated with the properties key. Remember that this lists out many of the earthquake's attributes. As you can see, these JSON objects are deeply nested within the overall response. But finally, we're at the level where we can access the individual values of the properties JSON object by referring to the key mag for magnitude, place for location, and time for the time in milliseconds that the earthquake happened. For now, we can extract all these values as strings because we're just displaying them straight to the screen and not doing any additional calculation or formatting on them. Then we can create a new earthquake object from these 3 strings. And lastly, we need to add the new earthquake to the list of earthquakes. After the loop finishes executing once per each earthquake in the features array, we will then build up a whole array list of earthquakes. Then we can return this list as the return value of the method. Great work. That was a very challenging problem with a lot of tricky Java syntax, so you should be proud of yourself for solving it. I'm going to go back now and add some more comments to my code. Alright, this looks good. Now let's test this code by calling this method. For step number 3 of the quiz, I asked you to modify the earthquake activity to call the query utils extract earthquakes method. So in this file, let's delete the fake array list of earthquakes that we created earlier. And let's call the query utils method now. There are no errors in our code, so let's run it on our device and see what happens. Awesome, our app now shows the list of earthquakes. This should look similar to the sketch we drew earlier when you parsed the JSON response manually in your head. If you want to reference any of the code we showed you, check out the notes below for the code diff.